Right, so we are on our first formative for Cycle 2A. This is going over the first 5 sections in the book. I know that we actually skipped 2.1, but I just threw it on there to make it look fancy or something. Okay, so question number 1. Given the formula below, which is the variation of distance rate, which is a variation of the distance rate times formula, distance equals rate times time, except this time I solved it for time. So if the rate increases, what will happen to the value of time? Will it increase, will it decrease, or will it just stay the same? So to do this, we're looking at rate, which is in the bottom of our fraction, the denominator. If we increase that value, what will happen to time? So the best way I think to do it is just to play around with different numbers. So for this first one, I said distance was 20 and my rate was 1. Okay, so 20 divided by 1 is 20. Okay, what if I increase, I'm going to keep the distance the same. I'm going to increase my rate. I'm going to increase it to 2. 20 divided by 2 is 10. Okay, so it decreased. I'm going to do it one more time to see if it's still decreasing or if something else happens to it. So I increased it to 4 this time. I kept distance the same, 20, and I increased rate from 2 to 4. So 20 divided by 4 is 5. So as rate increases, time will decrease. And I think my explanation is pretty good, especially since I have all of my work shown playing around with different numbers here. For number 2, we're going to simplify these expressions. We're going to combine like terms. So the first thing that I did was I highlighted the like terms. So the yellows are just the y's, the blues are the xy's, and the orange is just x. So from there, I'm able to combine my highlighted colors together. I do want you to show some work for these, so I would love it if you highlighted it or underlined what your like terms were so that I know that you know what you're doing. And then the next one is with these radicals, these cubed roots, fourth roots, and square roots. Again, I highlighted all the things that were in common, and then I was able just to combine them from there. The order of your answer, I'm not very picky about. I know some teachers are very picky about what order they go in. I personally don't care that much. And then moving on to number 3, we're going to simplify and show your steps for full credit. So the more work shown, the better, pretty much. So I'm first going to combine what's in my parentheses, following those order of operations, PEMDAS, parentheses go first. So 2 plus 1 was 3, and then I rewrote it, and then I'll square for the exponent. I'll square that 3, which just leaves me to a 9. And then I can do multiplication, which is highlighted. That's why everything is highlighted. It's showing what step I'm doing next. Negative 4 times 9 is the negative 36. And then from there, I just work from left to right. So I subtract 3 minus 36, negative 33 plus 5, and I get my answer of negative 28. For the next one, we have a lot going on. I also have a division bar or division sign right in the middle of my expression. If you want to change this into a fraction, because remember a fraction is just division, you totally can. I didn't mind the division sign right there. It didn't bother me too much, so I'm just going to leave it like it is. And I'll actually solve the left-hand side and the right-hand side separately and then kind of combine them together in the end. So for the left side, I did everything that was in the parentheses, and then in the parentheses, I have to still follow the order of operations. We have a negative 3 plus 8 divided by 4. I have to do division first because division comes before addition and subtraction. So 8 divided by 4 gives me 2, and then I can combine those together. And then I'll do the same, or I'll do the right-hand side now, do everything inside the parentheses. Order goes from left to right because it's just addition and subtraction going on in there. So then on the left-hand side, I combine -3 plus 2 to -1. And then on the right-hand side, 14 plus -12 gives me 2. I cubed the -1. Well, -1 cubed is just -1. It's -1 times -1 times -1. 4 times -1 is -4. And then -4 divided by 2 is -2. And then for this last one, it looks different than the one that you took on your formative, simply because I took it a step further this year and explained what each of those variables represented. A was your current amount. I also said P was for principal or initial amount, either the initial amount you borrowed or the initial amount that you have invested, however you're looking, from whichever perspective you're looking at compound interest. It can be used for borrowing money and paying interest, or investing money and gaining interest. Ours interest rate is 8%. 8% written as a decimal is 0.08. N is the number of payments per year. So this one you're paying 12 times 12 times a year. So you're having a monthly payment. And then T is the number of years you're paying this loan off for, or for how long you're having your investment. So this one is 6 years. Altogether, you're going to have 72 payments. So I'm going to plug all of these values in for the appropriate variable. Bam. So we notice that we are trying to solve for P, which is what the question asked was for us to find the value of P. So really we want to know what was the initial amount either invested or the initial amount borrowed. So I will start on the right hand side, and pretty much I'm just going to plug in 1 plus 0.08 divided by 12 raised to the 12 times 6th power. I'm just going to type that right into Desmos, just like I see it. Make sure you include your parentheses. Make sure that 12 times 6 is in an exponent, and you'll get 1.6135. I just rounded to 4 decimal places. I like rounding a couple decimal places in your decimals, just for a more accurate answer. And then we divide both sides by 1.6135. So we get P as $2,479.08. Now, again, either that was the initial amount you invested or the initial amount that you borrowed on a loan. This question didn't specify which was which. And then jumping down to question number 5, use the chart of gas station prices per gallon of unleaded gasoline to answer the questions below. So we have 5 different gas stations with 5 different prices per gallon. What is the mean gas station price? So what is our average gas station price? You can either use Desmos to find the mean. Remember, it's function, stats, then mean, and I can go 2.56, comma, 2.38, comma, 2.56, comma, 2.78, comma, 2.69. And I can find my average that way. Or you can add up the 5 different gas station prices and divide by 5. So you'd have 12.97 or $12.97 divided by 5. And, you'd get 2.59. And I have to round off to the 2 decimal places because we're talking about money here. So I don't want to add that 4 in on the end. For the next one, part B, what is the median gas station price? So I can either go to the beginning and I can erase the mean, go back to function, stat, type in median. Or I can list it from least to greatest. And what I did up here at the top is I listed them from least to greatest, but instead of using the numbers, I used the first letter of the gas station's name. So Thornton's was the cheapest, then Shell, then Citgo, then Marathon, and then Amoco. And then I just found the middle price, which is $2.56. Same thing that I just got on Desmos, $2.56. And then what are the weights assigned, or I'm sorry, if the weights assigned to each gas station were 10%, 30%, 20%, 15%, and 25% respectively, what is the weighted mean gas price? So for this one, we will list Shell is $2.56 times 10%, which is 0.1 as a decimal, plus Thornton's gas price, $2.38 times 0.3, which is 30% as a decimal, plus Citgo's price times the 20% plus, and I'm going to go over in my room here, 2.78 times the 0.15 for my 15%, plus $2.69 times the 0.25 for 25%, divided by the sum of the weights. So 10 plus 30, I believe it adds up to 100, but let's just double check. 10 plus 30 plus 20 plus 15 plus 25 is the 100%. So we'll divide by 1, which is 100% as a decimal. So then we'll type that all into our calculator, which is going to be a lot. 2.56 times 0.1 plus 2.38 times 0.3 plus 2.56 times 0.2, forgot my parenthesis, plus, times 2, plus 2.78 times 0.15, plus 269 times 0.25. Okay, and that is my weighted average is $2.57 for the weighted mean gas price. Why would we ever use weighted mean for gas price? This would be used if in maybe, let's say, a big city, so like Chicago, if 10% of the gas stations were Shell, and they all, just assuming they all had the same gas price, if 30% were Thornton's, 20% were Citgo, 15% Amoco, and 25% of the gas stations were Marathon gas stations, that's when I would want to know what the weighted mean gas price is, because if there's only one gas station, if there's only one Thornton's in the city of $2.38, but 100 Amocos, the average gas price really isn't the average between those two. The average is skewed more towards Amoco because there's so many Amoco stations versus the Thorns. Hopefully that made sense to you. If not, that's okay. We'll keep working at it. And then for the simplify, hopefully I don't need to go over these. If you need me to go over these, just shoot me an email and I would be happy to. But it looks like most of you are doing pretty well on simplifying these expressions based on the exponent rules.